All right, this is 4.3, and we're just talking about quadratic functions. So the first one says for the quadratic function f of x equals x squared plus 8x, answer A through C. So they're asking us to graph the quadratic function by determining whether its graph opens up or down and finding its vertex. So it opens down if A is a negative number. It opens up if A is a positive number. By A, I mean the number in front of the x. So we always are in front of the x squared. We have ax squared plus bx plus c. If A is a negative, it's going to open down. If A is a positive, it's going to open up. And in this case, A is a positive, so it's opening up. Good. What are the coordinates of the vertex? Remember, the formula for the vertex is negative b over 2a, which is, in this case, negative 8 over 2 times 1, which is negative 4, right? And that's just the x value. Sorry, it's been a few days since I've done this. The x value is a negative 4. And then what you want to do with that negative 4 to find the other half of that pair is take the negative 4 and plug it back into your equation. So my equation is x squared plus 8x, so that would be negative 4 squared plus 8 times 4. Good. Negative 4 squared is 16. 8 times 4 is, let's just be super careful, 8 times 4, you can tell I'm doing high level math, 32. 16 and 32. Is 48. Sorry, I already made a mistake. I was like, that's huge and won't fit on there. My mistake is that it's supposed to be times negative 4, right? So 8 times negative 4 is a negative 32. So it would be 16 minus 32 is a negative 16. Ignore that guy. So our point now is negative 4, negative 16. That's the vertex. So negative 4 on x, negative 16 on y. There's my vertex. What is the equation of the axis of symmetry? The axis of symmetry is just drawing a line through that point, and it's always a vertical line, right? Because your parabola is always opening either up or down. So if it's a vertical line, it's always going to be x equals. If it goes to the x-axis, it's an x equals, and then the x value of this point, negative 4, negative 16, the x value is negative 4. So at x equals negative 4 is my axis of symmetry. Good. Then it's asking us to find the x-intercepts. You're also welcome, you're just welcome to put that into Desmos, and if you can find the answer quickly, that's a perfectly legitimate way to do it. So, for example, here we can do x squared plus 8x. You can see that the vertex is negative 4, negative 16. You can see that the x-intercepts are negative 8 and 0. Good. Here it says, what are the x-intercepts? So you don't need to say negative 8, 0. You can just say it is negative 8 and it is 0. Sorry, I meant 0, 0, right? Those are the points, negative 8, 0, and 0, 0. But it's just asking the intercept, so it's just the x values of those 2 points. Good. What is the y-intercept? Remember, the y-intercept is always c. It's just the term c. So here we have ax squared plus bx plus c, but our whole equation is x squared plus 8, so there is no c. If there's no c, there's no y-intercept. Oh, sorry. Does not mean there's no y-intercept. It means that y-intercept is 0, right? Because if it's down here and it's opening up, it is going to cross the y-intercept. It's going to cross it at 0, 0. Determine the domain and the range of the function. So the domain is the x value. So if you think about the x value of this whole thing, so it's going to cross here, and it's going to cross here. Good. So on the x-axis, in both directions, it goes on infinitely, right? It never stops. So you would say from negative infinity to infinity on the x-axis. On the y, so that's my domain. My domain is always my x, negative infinity to infinity, but my range is my y, okay? The range goes up forever because of those two up arrows. So I'll end in infinity, but it starts at negative 16. Good. So the domain is negative infinity to infinity. The range is negative 16 to infinity. It is increasing. So increasing means the slope is positive. Good. Well, you're still moving that one. The slope is positive. So it changes, and we're just looking at the x values. This is x is negative 4. It starts increasing and it never stops increasing, right? So this is increasing. Good. If I read it like this and start going down, that's decreasing, right? So this half is decreasing. This half is increasing. So it's increasing on the interval negative 4 to infinity. Oh, I'm sorry. And it's decreasing from negative infinity to negative 4. Those are all our questions. We were able to graph it. So now for number 2, it's the same equation, but instead of a positive x squared, we have a negative x squared. So how is that going to change it, right? So if it's a negative, it's going to be opening down. A negative, and it doesn't matter if this is negative, it's only the a. A is negative, it's going down. If a were positive, it would be going up. What are the coordinates of the vertex? So the x value of the vertex is negative b over 2a, which is negative 8 over 2 times a negative 1. Okay, because that negative sign means it's a negative 1. So that's positive 4. So the first term is 4. Now I plug that 4 into my equation. Negative 4 squared plus 8 times 4. Good. The negative is not affiliated with the square, so it's negative 16 plus 8 times 4 is 32. So that's still negative 16. So it's a positive 4 and negative 16. Still down here, but now it's on this side. That's my vertex. Good. 4, negative 16. The axis of symmetry is x is 4. So here's my axis of symmetry. Good. What are the x-intercepts? Again, you feel free to graph it, or you can say y is 0. So 0 equals negative x squared plus 8x. And then you can factor it, sorry. So I can take out an x from both of those, right? And I get negative x plus 8. So now I have x is 0 and negative x plus 8 is 0. So x is 0. So one of my points is 0, 0. And the other point is, I'll move that x over, 8 is x. So 0, 0 and 8, 0 are my x-intercepts. But I think they just want it like this, 8 and 0. My y-intercept is when I turn the x's to zeros. So y is 0 squared plus 8, sorry, negative 0 squared plus 8 times 0, which is y is 0. So the y-intercept is 0. We know that because this is 0, 0. The domain and range of the function. So the domain is x. It goes forever in both directions. So from negative infinity to infinity. But the range is from, again, negative 16 on the x to infinity. Because it is opening, it's opening down. So instead of that, it's from negative infinity to one second. All right, I just graphed it on Desmos, and it's actually a positive 16. So I think this negative is supposed to be included in the squared, and so I think it's actually a 16. No? Oh, okay, no, it is still a negative. So negative 16 plus 32 is positive 16. Sorry, I added those wrong. I was wondering, shaking my very foundations of math. Okay, so I said that was negative 16, but it's actually a positive 16 because I was thinking if it opens down and that's the point, it's never going to have any x or y axes. But it's actually positive 16 because negative 16 plus 32 is positive 16. Sorry. So here's positive 16, positive 4. It's again going through 0, 0 and positive 8, 0. And it goes on forever. So the range is from negative infinity to a positive 16. Good. It is increasing from negative infinity to a positive 4 on the x, right? And then it's decreasing from a positive 4 to infinity. That's number 2. That's all they asked us for number 2. For number 3, we have x squared minus 2x minus 3. So is it opening up or down? We're just looking at the first term for opening up or down. That opens up because it's a positive. Good. What are the coordinates of the vertex? You're welcome to graph it and find the vertex. So we'll say x squared minus 2x minus 3. My vertex is 1, negative 4. The equation of the axis of symmetry is always the x value, so it's x equals 1. X equals 1. So it's that blue line, that's the axis of symmetry. The x-intercepts are 3, 0 and negative 1, 0, so negative 1 and 3. The y-intercept is negative 3, or 0, negative 3. And what is the domain? So the lowest point is 1, negative 4. Let's go back here. The domain are all the x values. So for each of these problems in 4.3, the domain is going to be from negative infinity to infinity. Good. The range now, so we said it was, the vertex was 1, negative 4. The x-intercepts are negative 1 and 3. and it goes forever, right? So my vertex is 1, -4. My y value of that vertex is -4. So my lowest point is going to be -4, and it's going to go up forever. So that's my range. My range is always my y values. So from -4, to infinity is my range. Where is it increasing? Where is it decreasing? So this is always on the x-axis, right? So at x is 1 is when it changes. So it's decreasing from -infinity to +1. And then it's increasing after that. So from 1 to +infinity. Okay. That's number 3. Number 4 is x squared plus 6x plus 9. So we see a vertex at -3, 0. We see the axis of symmetry would be x equals, and the x value of that vertex is -3. Is it concave up or concave down? So is it opening up or opening down? It's concave up because that x squared is a positive. Good. It asks us to find the y-intercept and the x-intercept. So the x-intercept is -3. The y-intercept is 9. Good. The domain is from -infinity to infinity, if we're just looking at that graph. And the range is from 0 to infinity, because this line is y equals 0. Right? So it goes from there forever up. So these are my answers. I said that we were at -3, 0 for our vertex. I said that the axis of symmetry is x is -3. The x-intercept is also -3 because -3, 0 is an x-intercept. The y-intercept is at 9. The domain is all real numbers. The range is all the positive numbers starting with 0. Good. It is increasing and it is decreasing. So you see it changes right at -3, 0. So before -3, it's decreasing. So it's decreasing from -infinity to -3. It's increasing from -3 to infinity. Good. Now it's also going to ask us, sorry, where f is above 0 and where f is below 0, or where f is positive and where f is negative. Good. If I look at my graph, which I didn't even bother to graph, but it was at -3, 0, right? And it went up, up. So when they say where is it above 0 and where is it below 0, it's f of x, so it's y. Y is above 0 always, okay? It's everywhere on this graph, it's above 0 except at this dot. At this dot is equal to 0, right? So f is greater than 0 from, so I would put in here, from -infinity up to that point, up to -3. It doesn't include -3. And then it keeps going towards infinity. So it's always above, except where it's right on. And it's right on at x equals -3, right? So where f of 3 is 0, right? All other f of x's are positive except f of 3. So that's how we would write that. That goes here, and it is never negative, right? Number 5, we have 2x squared minus x plus 4. Two x squared minus x plus 4. Good. The vertex is 0.25, 3.875. The axis of symmetry is x equals 0.25, right? The graph is concave up. The x-intercepts, there are no x-intercepts, right? Because it's above the x-axis and it's going up forever. The y-intercept is at 0, 4, or just the number 4, right? And that we know is true because this c is 4, c equals 4. So that will tell us where our y-axis is. And then it asks us, so we saw that, right? We put negative, or sorry, we put 0.25, 3.875 here as my vertex. We said the axis of symmetry is whatever our x value was equals x. We said it's opening up. There are no x-intercepts. There's one y-intercept, which is the same as c. And they're asking us to use that information as though we haven't already graphed it. So I know it's opening, it's concave up, right? So it can't be C, it's concave up. The vertex is positive. Oh, it can't be D either, because D is not concave up. The vertex is 0.25, 3.875. 0.25 on X is going to be on this side. 3.875 is going to be up here. So this is actually on the negative X. This is positive X. So just based on that, I think it's A. And then the y-intercept is 0, 4. 1, 2, 3, 4. That y-intercept is higher. So I would say it's A. Find the domain and the range of the quadratic function. So the domain is all real numbers from negative infinity to infinity, because all quadratic functions have a domain of negative to positive infinity. The range is from 0.25 to infinity. Good. Nope, sorry. The range is from 3.875 to infinity. Good. It is increasing from 0.25 to infinity, and it's decreasing from negative infinity to 0.25. Okay. So if we look at our graph, where is it increasing and where is it decreasing? Or sorry, where is it positive and where is it negative? It's always positive. It is increasing on the interval all real numbers, and it's never negative. Good. All right, now we have negative 2x squared plus 2x minus 6. The vertex is negative 2x plus 2x minus 6. Good. All right, so here we have the vertex is 0.5, negative 5.5. The axis of symmetry is x equals 0.5. X equals whatever your x value is. It is concave down because that a value is a negative. The x-intercepts, there are no x-intercepts because it opens down and it's concave down. The y-intercept is 0, negative 6, or you can just say negative 6. The domain is all real numbers. negative infinity to infinity. The range is between negative infinity, right? It's always going down, between negative infinity and negative 5.5. Good. Where is it increasing and where is it decreasing? It's increasing from negative infinity to 0.5. And it's decreasing from from 0.5 to positive infinity. Good. Then it asks, where is it positive and where is it negative? It is negative everywhere. It is negative from negative infinity to positive infinity because it never crosses this x-axis. Good. So it would be never positive. Number 7 looks the same. Instead, it's negative 4x squared plus 2x plus 4. So it is opening down. The vertex is 0.25, 4.25. The equation of the axis of symmetry is x equals 0.25. The x-intercepts are, and I should mark them for you, negative 0.781 and 1.281. The y-intercept is 0.4 because it ends in 4, right? That right there gives us a positive 4. And the domain is all real numbers. The range is negative infinity to 4.25. Okay. The function is increasing from negative infinity to 0.25, and it is decreasing from 0.25 to positive infinity. And then if they ask, I don't think they asked though. If they asked where this was positive and negative, I would say it is positive from negative 0.781 to 1.280. So the way you would write that is from negative, I'm trying to think how to write it. I'm still sure. So what it looked like was, this is 0.781. This is 1.281. Oops, sorry. Good. So it's positive here, and then it becomes a negative right there, right? So after that, it's on the negative side. So it is f of x is less than 0 at negative infinity to 0.781, sorry, negative 0.781. And from 1.281 to positive infinity. It's less than 0. And then it is greater than 0 between them, between negative 0.781 and 1.281. Good. All right, the last ones are shorter. Determine without graphing whether it has a maximum value. And sorry, you got this wrong on the exam because we didn't do it before you took the exam. But a maximum value means that. A minimum value means that. So if it's concave down, it has a maximum value. If it's concave up, it has a minimum value. The quadratic function with a negative a has a, it is a negative, it's opening down, so it has a maximum value. Does that make sense? This one, it's opening up, right? So it has a minimum value. This one, it's opening down, so it has a maximum value. This one is opening down, so it has a maximum value. That is it. I hope that helped.